Hello, Honors Chemistry, and welcome to Reactions, the last sections of the Chapter 11 outline, where we reincorporate, ding, 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 Chapter 7, Types of Reactions, Chapter 8, Reaction Stoichiometry, and, of course, Chapter 13, where we talked about the concept of solutions and molarity, right? All of that gets wrapped back in. Do be mindful, obviously, these introductory problems from your textbook aren't going to feel as hard because oftentimes they will give you the reaction and they're not going to incorporate all the little tidbits, right? But no worries, because don't worry, there's a practice coming up, a mixed practice where I will obviously help you by giving you more thoughtful practice. Okay, but anyway, starting off with some stuff from the book, right? Don't forget, anytime we are presented with the concept of moles of A, and I want to get to moles of B, what is the only conversion that allows us to convert between substance A and substance B? Right, that would be our mole ratio, which comes from, right, the balanced coefficients from a chemical reaction, right? Which means that when we're reading this problem, it says in this reaction, so it gives you a reaction, which, you know, is kind of like a duh clue, right? But even if it didn't, right, it says that we have this volume of oxygen, right, and it gives us a pressure, and it gives us a temperature, and it asks us about grams of something different, right? So that's always your clue, right? Even going back to chapter 8, right, if we're given information about one substance and we want to know about something else, that's your clue that at some point you have to incorporate a mole ratio, right? Which means that we need to know how to go from all of this information about oxygen to figure out, ding, 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 moles of A using PV equals nRT, yes? As in that's going to be our ticket into moles.
Silverware, then cadmium and indium, tin cans, antimony.
So after doing that math, we see that N is equal to 0.178 moles of O2, right? And then we would do a mole ratio to get from moles of O2, which is 1 mole of O2, is equal to 2 moles of Ag2O. And then last step would be, right, molar mass, right? So for every 1 mole of Ag2O, we would go look at a periodic table and figure out what its molar mass is, and that's what would give us our final answer. Yes? All right. Next up, molar volume, right? So here, we throw in one special tidbit, right? If we are at standard temperature and pressure, which is what conditions? Right, 0 degrees Celsius and 1 atmosphere. Anytime we are at this temperature and this pressure, right, going back to the fact that all of our gas information is going to be filtered through PV equals nRT. So if we are at 0 Celsius, if we are at 1 atmosphere, right, what that means is that we know that 22.4 liters is equal to 1 mole, right? Molar volume, the number of liters equal to 1 mole, molar volume, right? Just like molar mass is, right? The number of grams equal to 1 mole, molar volume follows suit, right? So anyway, this conversion factor applies anytime we are at standard temperature and pressure to make your math a tiny bit easier. So instead of having to go through PV equals nRT, we can just use that as a conversion factor, right? Likewise though, right, if you forget about the concept of molar volume, really, you would just plug in these into PV equals nRT, you would discover that, right, and you would follow the problem the exact same way. So even if you were to forget the concept of molar volume applies at STP, you should still be able to solve the problem. But anyway, it is a shortcut though, like we'll see here. So how many liters of oxygen, right, so this is my question, are required to form 10 grams of H2O? So if I have 10.5 grams of H2O, right, and I know that for every 18.02 grams of H2O, I have 1 mole of H2O, then I would look at my equation to get the mole ratio, which says that for every 2 moles of H2O, we would produce or require 1 mole of O2. And then here is where that shortcut comes in. I would like to know volume of oxygen, right? So if I did not recognize that whole molar volume thing, I would have to stop here. Oh, geez. I would have to stop here, and this would get me my moles of O2, right? Which I could then subsequently plug into PV equals nRT, right? To solve for my volume, and that would work, right? But if I recognize this special condition of STP, then I also know that there are 22.4 liters of O2 for every 1 mole of O2, right? Going back here, right? And then that conversion factor will allow us to get that job done a little bit faster. Yes? Makes sense? All right. That's all. All right. Thank you for listening. Be good, and I will see you for lots and lots of practice. All right.